Sergey Ryabov. I work at Facebook right now, but before that, I had a bunch of topics that interested me, and I had pet projects on RX Java explorations. Aside of that, I also love Kotlin, and I use it even before it was 1.0, and I was very excited when they announced multi-platform features. So today, I wanted to talk about what you can do with RX in Kotlin multi-platform. So last year, I gave a talk about how to apply MVI. I think here is, by the way, maybe you've seen this talk. Can you raise hands if by any chance you've been to Droid meetup? This probably will be required for you to understand the code for this talk, but it's not required for the talk itself. So the approach itself was quite platform agnostic and kind of based on Kotlin. So why not try to use it in a multi-platform world and have benefits for both of the applications, Android and iOS. But on the other side, we heavily were based on RX Java, and that means, sorry. I had a conclusion in that talk, had a dream that maybe someday we will have RX Kotlin library that will be multi-platform, not that wrapper, that is available for everyone right now. So fun stuff is that this year, in March, I actually was approached by my friend who pointed out to Reactive repository. Guys from Badu were basically trying to make my dream come true. And same month, after maybe a couple of weeks in April, Roman Elizarov, who is responsible for developing Kotlin libraries, he announced early preview, developer preview of Flow based on coroutines. That's kind of Kotlin's approach on processing reactive streams. So fast forward half a year, we have right now Reactive 1.0.1 available, kind of stable, and we have Flow that is stable since coroutines 1.3.0. Very important thing here is that it is actually supported by SQLite already as a public-facing API and by Room, so Google is betting on that as well. Let's check out how public APIs differ from RX Java. That's a simple code that you are probably familiar, all of you are familiar with. We just create some observable, do filtering, mapping, and then collect results. That's how it will look like in Reactive. Basically, the same thing, just a different builder of observables. And that's how it will look like in Flow. Also, not much difference, right? We have slightly similar approach to processing the stream. In a nutshell, probably you've seen already that these two interfaces are the basement of Kotlin Flow library. And we don't have much of an operators here, right? So where are these flat map, filter are coming from? Interesting decision here is that the whole library is based on an extension function approach. So all the operators except collect are built as an extension functions. Let's look at the map example. Map is quite simple. Let's try to understand how it works under the hood. That's basically the implementation from the library itself. And let's make it a bit more clear to understand what's happening here. Let's start from the beginning. First of all, we are subscribing or collecting the flow that we are calling map on. So upstream, we're collecting this upstream. And then we emit or do on next for the flow that we created inside this operation. So inside map, we created downstream, collecting upstream and pushing everything after transformation to the downstream. Quite simple, very easy to understand, just 5 lines. Let's look how it will be in Reactive. Slightly more, and actually if you will spend a minute, you will see that approaches are not much different. Here we also subscribe to the upstream, then using emitter from the newly created downstream, we put new items items there after transformation. Some fancy stuff here is that we also need to implement observable pattern. And here we are using this, like they are using quite nice trick of Kotlin delegation, where you don't need to implement on error and on complete, you just delegate this to like default implementation. And also one simple bit is subscription, where we keep track of disposables. Next question, how it may look like in RxJava? Well, probably you already know that, and I gladly won't follow through all these lines here. Probably that's the power of Kotlin. I would gladly agree with that. So let's dive deeper into the API side of this. First of all, we're interested in the set of operators, right? Like in RxJava, we have operators for like each case of our developer life. What's about these new two libraries? Gladly in reactive, we don't have much difference here. Almost the same set of operations is available for us, so that will be just one column. And with Flow, it's a bit different. With Flow, we are having more opinionated view on the naming, because Flow also should have been respectful to their standard collections library. So some of the functions are just like basically synonyms of that. So here you may see that our concat map and switch map that you're familiar with are actually called flat map concat and flat map latest. Arguably more, this kind of transfers the intention more clearly, but I'm just too used to RxJava naming. These are not like extensive list of operators, also because we have something missing, and mostly we have something missing in Flow. They have kind of a pragmatic approach on the operator set, and they see the situation like we need to provide the absolute minimum set of operators, and then you can implement everything else by yourself. It's quite easy with Flow. So what we don't have that we probably may use quite often with RxJava? Grouping, publishing, sharing, replay, that's quite useful when you do with when you cope with several streams of data. These all are not available, and you will need to implement them by yourself. Actually, share operator is very much requested by the audience, so they have an ongoing discussion about how to implement this. You can also participate in that, give your opinion on what their decisions are, and hopefully we'll see it quite soon. Others are gladly provided for us by David Karnak. Who knows who David Karnak is? Yay, awesome. So like David Karnak is the main maintainer of RxJava library, and he could not pass Flow unnoticed, and he provided some of the operators that were missing with his own implementation. Sad thing here is that that's only JVM based. You can see the implementation. It is heavily influenced by the RxJava implementation, so they will be familiar for you. And actually, you can try to implement them in multi-platform world if you will replace something like atomic references and all that concurrency stuff by multi-platform Kotlin features. But that's not the thing in reactive, because in reactive we have most of the operators available, and it's time to check out how it is with threading, because you haven't seen any subscribe on or observe on operators in the list, right? So with reactive it's the same. They have these two operators, and the overall approach to switch threads is the same. We basically use subscribe on to propagate threading notation to the subscription point, to the head of your stream. And we use observe on to change our threads in the downstream. And this last example will be affecting the subscribe operator. It's different in Flow, and that's what's tricky here. So first of all, you may remember that in Flow signature, in Flow interface, the signature of collect was suspended. And that means that we cannot just subscribe to this stream anywhere. We need to do that in the coroutine. So first of all, we need to launch coroutine with the coroutine builder. And then we have this flow on operator, no observe on, no subscribe on, and flow on works differently. It actually propagates its effect to the upstream. Everything that's up the separator will be affected and change the dispatcher or change the thread pool where items are emitted and calculated. Same situation with this map, but what about collect? Like collect doesn't have any flow on afterwards. Where is it emitting items? Here takes place the dispatcher from the launch builder, and that's what makes things a bit trickier. We don't usually go just upwards, we also go downwards, depending on which operator we're executing. So collect on will be affected only by coroutine builder. That's something to get used to. Maybe not that easy to cope with for the first time. We have these operators that are changing the threads, but what are schedulers' analogy in the flow? We also have this handled by reactive and with flow as well. For most of them, like for the most useful of them, main thread, I/O scheduler, and computation scheduler, we have analogies. But for something more not so often used, we need to come up with different approaches. So like for RxJava, we have this trampoline, new thread, and single scheduler. And for what's missing in reactive and flow, we have these extension functions that are helpful to convert, in reactive case, RxJava schedulers to reactive schedulers, and in flow case, Java executors to flow dispatchers. As you may follow already, if it's Java and RxJava in place, that only is available for JVM. And sad thing is that dispatcher.io is also available for JVM. So no counterparts in JS or native worlds. Last bit from the public API is subjects. We do use subjects extensively, especially when we connect separate parts of our application, separate components. And in RxJava, we have mostly used behavior, publish, and replay subjects. What do we have in reactive? We have two of them, and that's kind of enough most of the time. But with flow, we only have behavior. Something like an analogy for behavior subjects, it's called conflated back broadcast channel in flow. It is based on channels, like name applies. And that also brings the performance applications of channels. So right now there is an ongoing discussion also to bring this like to our native flow world and create the data flow thing that will be basically behavior subject without channels at all. For those who want to use flow on JVM, again, David Karnak has our back, and he implemented all this stuff in his own way, but also only JVM. Public API difference is kind of clear. What else do we need to take into account when implementing all this in our application, when using this in our application? First of all, if we would like to follow with one or another library, we would like to understand how to gradually approach the adoption of this library. Let's say, first step, you may probably need to connect different components of your application. For example, you have an API module which returns observables because you're using retrofit interface. And you're using another library in the business logic. So here comes the bunch of artifacts that are helpful to convert from one kind of reactive stream to another one. Coroutines can be interoperable with RxJava, and reactive can interoperate with coroutines and RxJava both. Second thing, when we actually are bought by these libraries, we will try to rewrite some stuff using this new approach. Means converting the component itself, the internals of that component. Here is the nice thing, and I would say clever approach that Kotlin people came up with. It is called migration. Like in this class, in migration.kt, you will have a bunch of helpers to help you convert from RxJava to Flow worlds. And that is a nice and tidy approach of using the deprecated annotation for Kotlin. Like, as you may know, deprecated annotation is can also provide us the hint on which code can be used to replace the code you have right now. So here, something that is in replace with attribute will be used if you will just apply quick fix in your IntelliJ IDEA. So basically, in this migration KT, you will have stubs for all the operators in RxJava for everything that is inside observable, and you just need to change the type of your upstream from observable to flow, and then everything will be highlighted as deprecated, and you can just follow the steps and apply Alt-Enter to change to appropriate operator for flow. Like here, we don't have flatten, we have flatten concat. One interesting thing to take into account is a difference in error handling, or maybe gotchas, some gotchas in error handling. So that's a simple, very small pipeline for handling our data, and we know that the crash map inside flatmap can crash. What will happen if this crash map will crash in this case? We will catch the exception and report and handle it. What will happen if we are changing this? So like flatmap won't crash, but something in on next can crash. What will happen here? In RxJava, we also are covered. Like it will be handled in report. And same situation with reactive. Reactive has the same semantics. What will happen with flow? If we will use flow here, our IDE will highlight the deprecations. We will change flatmap to flat merge. Subscribe, there is no such operator. We will also change it to catch to handle errors. And instead of on next, we will use collect to collect the stream and process the stuff. So here again, we have crash handle that can crash inside the collect operator. What will happen here? Who thinks that the thread will be handled by report function? Can you raise your hands, please? And who thinks that it will crash? And you're right, it will crash. And it will crash because actually the same thing as in flow on operator. Flow on affects everything that's on the top of it. And here, catch affects everything that's on the top of it. When we have crash inside collect, we are not covered here. So the correct approach of migrating to flow here will be using on each operator. And in that case, you should be attentive to where is your error handling put, and that needs to be the last operator before collect. Actually, that is kind of just the tip of the iceberg. That is something that you can see from flow, but there are other things that are very tricky about handling exceptions in coroutines. Depending on what coroutine builder you are using, launch, async, or others, you may have different effect of crashing inside the stream. And there is an article and there is a repository for reproducing this kind of tricky behavior. I highly encourage you to check this out. Link will be in the end of the slides as well. Actually, that's like repository is quite old, but nothing changed since then. So, we are talking about multi-platform, but since the beginning, only thing that we hear is that this is not available, this is available only for Rx, for JVM, and that is available for JVM. What is the situation with Kotlin native in the end? With Flow, it is bad, because single-threaded coroutines, that's the only thing that is supported. And as a consequence, we have only single-threaded flows supported. So we cannot actually do transfer our computation to I/O, for example, or to computation. We may do this strictly in one thread, but you can create flows in a different threads. You just cannot transfer data. With reactive, they tried to solve this problem, and that's actually a big benefit of that library, because they have worker-based threading, and they consume the notion of freezing and native memory model, and they actually supported that. So that affects performance, but you at least are safe and you're capable to do that. you can freeze the data that's switching threads to evade memory leaks. Or if you know that some data that is passing your stream won't be transferred to another other threads, you can use thread local operator that will basically say that we don't need any freezing, we can use this like mutable data as is. Obviously, you can say that we already are operating with immutable data when passing this to the flow. Like usually we're kind of transferring, converting one event to another event, and then put this inside the observable, for example. And that is usually immutable. But the case here is not about data mostly, it's about callbacks. So when you are transferring from one thread to another thread, all the stuff that is captured by the callback will be frozen. And that's a big pain. That's where you need to kind of you need to pay attention as well. So for example, when you are collecting your stream to an array list, you cannot just add things to an array list. You need to create a new array list for every addition. It's like copy on write array thing. Obviously, important thing is what's about performance? Like that's a bunch of new libraries here. We know how RxJava works. That's like the top-notch thing for data processing right now, and how these new stuff can cope with. I've done a couple of benchmarks that are usually used for comparing reactive streams libraries. That is basically make our libraries play Scrabble over Shakespeare texts. That's something kind of standard. I also added a link to the repository and explanation post by David where this approach came up from. But I took the RxJava implementations from David's repository, flow from coroutines repository, and I implemented reactive benchmark myself, and that's the actual results. So you can see here that flow is really fast here. The smaller number is better. Basically, the number of operations number of milliseconds you are wasting for an operation. Flow is the fastest one. It even beats the RxJava, both observable and flowable. And here we can see that reactive is very slow here comparing to others. I actually reached out to the maintainer of the library and spoke with them why that may be the reason. And they explained me that the hard part here is this support of Kotlin native. So when you need to support Kotlin native memory model and you need to freeze this stuff between thread hops, this also can affect the JVM performance. Another thing is that I spotted that flow benchmark actually doesn't use flatmap where it is used when it is used in RxJava. It uses flatmap concat, and that's why it's so fast. When you're switching this benchmark to use flatmap, actually flow benchmark becomes 9 times slower, and that's like a huge no-no. Probably for most of your cases you can switch flatmap to concatmap, but here is the kind of underlying reason. The flatmap to merge all this stuff, flatmap actually uses channels, and channels are known for their not so good performance in coroutines. That's probably something to be addressed in the future, and I really hope that this will be improved. Flow doesn't feel very well using flatmap. Second thing that's kind of interesting is memory allocations, because we are on mobile, we care about that. And that's the situation with memory. RxJava consumes the smallest amount of that. They kind of optimize this stuff really heavily through the years. Then we can see that flow is on par with RxJava 1, and that's kind of nice as well. Here reactive is again showing itself like not in a good spot, but the best thing here is to actually see that flat mapping stuff allocates like a huge ton of memory here, and we basically have quite big problems here. Also, when using this on mobile, I think you will be affected like 3 3 times. So, conclusions. I would say that flow is an interesting approach, but it has a different mental model, and you need to come up with your own picture of how things work to easily be able to convert from one methodology to another one. Just some time to get used to. Native is not supported yet, so you can use this in simple applications that don't use any background threading stuff, like you don't use I/O scheduler, your maybe network is very lightweight or something, because obviously that's when we suspend with coroutines, we are not blocking the thread, so that's different. And we actually can get away a lot of problems just because of suspension, not blocking the main thread. Not all operators are supported, but that's something that can be dealt, and this can be added later on. Some of this simplest one you can implement even yourself. What is the most interesting here is that flow and coroutines is something official from JetBrains. And also, they have a huge support from Google. Like Google puts coroutines in their examples right now. Everywhere in code labs you will see coroutines. You have coroutine scopes in viewModel libraries. And right now, Room also supports flow as an output. So that actually brings to use this. Reactive, on the other side, has very familiar API. Basically, it's the same. You just don't have any period of getting used to this. It actually supports native, so you can use this in your iOS applications or multi-platform applications right here, right now, after this talk, even before that. One thing to highlight is that they don't have support of back pressure. Back pressure is a very complex thing, and you can see how flat map, for example, or even map for flowable, not for observable, are implemented in RxJava. They are even bigger than the slide in the beginning. And flow, on the other hand, supports back pressure just because of the suspension. That's something that's very native in the nature of coroutines. The library is 1.0, but I would say it's not really production ready because of things that popped out when I was testing the library. So like some applications of native implementation to JVM, it affects JVM as well. I would say you will need to look through the source code to understand what's happening there, because there is not much of a documentation right now. But this is something that's worked on, and that's good. That's the topmost thing here, is that the maintainers of this library, they are very responsive. So like I work closely with the main maintainer of the library when I was doing my benchmarks and doing my tests. And you will get your response, or like you will understand how to do this and why is this not working very quickly if you will reach out. And that's actually very, very awesome stuff, because this morning, then I woke up, I saw that the maintainer pinged me and said that they actually published another version of library where they addressed the issues that I stumbled upon. And that's what I saw after running benchmarks. So it's basically twice of the improvement just because they separated stuff that was handling native memory model just to the native module. And JVM stuff is working on a pure JVM APIs. And you can see here that they are not so far from RxJava 2 as well. So that's something very promising. Just like magically, you won't have any big performance implications here. On the memory side, it's a lot better as well. Twice of an improvement from the previous version, and slightly worse than RxJava 2. So that's kind of a good example of how you support your users, I would say. Links. Basically, you will check this out at home, I would guess, when I will post the slides, but links to the repository of the reactive, some documentation. post of David Karnak for the nature of where this Scrabble benchmark came up from and how they actually measure the performance. Sample code for this talk will be published during the weekend, so don't scream on me when you won't see it on GitHub. And some legal stuff. That's it for now. I guess we have some time left, and I would love to show you how the migrated part of the MVI sample app looks when using Flow. So like that's a piece of code actually responsible for wiring up all the MVI stuff. Like you have some events coming from the UI, and you have some state that is brought to UI to be rendered. So like that's a typical example of how RxJava is used. We have incoming actions from the UI. We just combine this with the current state, do all the reducer stuff to get the new state for our application, and then put this into state relay to be able to subscribe to it when our view will be resumed. And the same thing here is for side effects, where we subscribe our middleware to the incoming actions to process it and do actually like whoops. This is how it will look like for Flow in multi-platform approach. You have the same thing basically, but you need to convert this instead of behavior subject. We will use this conflated broadcast channel, and you need to convert this to Flow to be able to subscribe to that. Overall, it's the same. So you can see that we are using the same operators. We are combining this with reducer to get the new state from the incoming action and state. We are subscribing to the state relay to keep to cache it basically when our UI is not active. One different thing is this launch. So instead of subscription with RxJava, we're using launching coroutine inside the scope, and scope is something that is managing our unsubscription after the application is paused, for example. Same thing here with middleware. So actually for subscribing, you don't need to keep track of that composite disposable anywhere and then manually dispose this somewhere in your on pause, on stop, or on destroy method. You just need to provide the scope for that. That will be the boundary of your pipeline. And in Android, it's quite easy. In Android, you have lifecycle scope that is provided by the support libraries, Android Jetpack libraries. And you have view model scope that is provided by Jetpack libraries. But actually for iOS, it's not so hard to implement this by yourself. We can basically do this helper that just implements the coroutine concept scope, and we can instantiate this in our view controller and then manually cancel this in like when view will be going to the background. One thing to highlight, according to the limitations of native, Kotlin native, we don't have suspend functions in iOS because that's not something that can be transferred to Swift. So that's why all the management, all the state management, all the stream management should be done inside your multi-platform code, and then you should use something like subscribe to the scope in your iOS view controller, and that's it. That's it for me. This code will be available on GitHub for more thorough inspection with an iOS example as well. and I would be happy to answer your questions. Thank you very much.
If you have any questions, please raise your hand. I'll bring the microphone over.